In this video, we're going to learn how to rewrite equations in vertex form. So to rewrite an equation in vertex form, the best way to do it is to use completing the square. So vertex form is that y equals a parentheses x minus h close parentheses squared plus k. So to get an equation in vertex form, let's follow these steps completing the square. First of all, when we're completing the square, we need to get the 2 to go on the other side. And then we need to check to make sure a, the number in front of the x squared, is 1. And in this case it is, so we can move on to the next step. To complete the square, we're going to take the term in front of with the x, the number in front of that x is a 6. We're going to cut that in half. And then square it. So half of 6 squared is going to be 3 squared, which is 9. And we're going to add that to both sides of the equation. Y plus 11 equals x squared plus 6x plus 9. So the whole point of doing that was because this is a perfect square trinomial that we can rewrite like that. And then last step is to move the 11 back over here and get y equals parentheses x plus 3 close parentheses squared minus 11. So the whole point of doing that was to get our equation in vertex form. And vertex form looks like this. Y equals a parentheses x minus h squared plus k. And hk is the vertex. Why do we need another form to write these equations? Well, because this format tells you the vertex just by looking at the numbers in there. So the vertex of this equation is -3, -11. This number here is the y coordinate of your vertex. And this number here is the x coordinate, but it's opposite, right? Because there's a minus sign here. So we need to take whatever's written here and make it opposite so that that negative gets factored in, right? So -3, 11 is the vertex for this problem. This problem didn't ask for it, but I'm still going to write it out for you. All right, so for question 1, the actual answer is y equals parentheses x plus 3 squared minus 11. I'm just trying to undo it enough so we can see the answer. So the answer is right here. That right there. All right, another example. We have y equals x squared plus 14x plus 40. And in this question on Delta Math, they're going to ask us to write the equation in vertex form and also tell us the vertex. So first step is to do minus 40 to both sides. Y minus 40 equals x squared plus 14x. A, the number in front of x squared, is already 1, so you can just go on to the next step, which is we need to find that magic number. What number are we adding to both sides? So we need to have 14 and square it. So that would be 49. We're going to add 49 to both sides. So this can be simplified to y plus 9. And this can be factored. I need 2 numbers to multiply to 49 that add to 14, 7 and 7, right? So x plus 7 times x plus 7, which can be written like that. And then to get it in vertex form, I need to move the 9 back over here. So y equals x plus 7 squared minus 9. So this is the formula, or this is the equation in vertex form. And then the vertex is the number in parentheses. It's always the opposite of what that says. And then the y-coordinate is always the number at the end, and it's exactly what's written there. So it'd be -7, -9. So this question has two things you have to type in. All right, question 3, same process. This one just asks for the vertex form, so I'm going to move the 2. I'm going to find the magic number by taking -10, and I'm going to cut it in half and get -5, and then I'm going to square it and get +25. That's the magic number. Let's add it to both sides. Let's simplify this to be y plus 23. Let's simplify this. I need two numbers that multiply to 25 that add up to -10. That'd be x minus 5 squared. And then last step, move the 23 over here. Get y equals x minus 5 squared minus 23. So that's the answer to this. This question is not asking, but if you did want to find the vertex of this would be 5 -23. It's always this number opposite, so that's why it's a 5, and so is this number exactly as written. All right, so that's all the examples today. Thanks for watching.